Hello and welcome to lesson 8. Today we're going to be looking at inverse functions. So we've kind of talked about this a little bit when we went over range. We went over mechanically how to do this. But today we're going to talk about why they exist and why we do them. So an inverse function is essentially the opposite of a function. So if we go over to the board, there we go. So in math, pretty much everything we can do forward has a backwards component. So the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of having a power is having a square root of that power. So today, the opposites we're going to look at is we're going to look at a function and the inverse function. So the inverse function just undoes what the function does. Pretty straightforward in terms of concept. Now let's actually put it into practice. So if we have a function, so let's say we have a function, let's go with 3x minus 2. So if the function 3x minus 2 multiplies by 3, so it's times 3, and then subtracts 2, the inverse function needs to do the opposite in the opposite order. So if this is f of x, then f inverse of x needs to basically be that but double reversed. So instead of minus 2, we're going to do plus 2. And instead of times 3, we're going to do divide 3. But we need to do them in that order. So we're going to start off with x. So we have x. And then we're going to do plus 2. So we've added 2. And then we need to divide by 3. So we're going to put over 3. So the inverse of 3x minus 2 should be x plus 2 divided by 3. Now, this is what we call the conceptual level of this problem. So this is the main idea, but it's not the procedural way to solve it. So this isn't the way most people are going to do it normally. This is the kind of thing where it's like, oh, that's a neat thing that we can do that reverse and reverse order, but typical, like, standard operating procedure is not to do it that way. So now that we have an idea of what our goal is, let's look at how we actually do this. So the way that we're going to get this done is we're going to start by changing this f to a y. So y equals 3x minus 2. And then we're going to do that thing we did when we're looking for the range. So we're going to switch the x value and the y value. So now that we've switched x and y, so it'd be x equals 3y minus 2, we're going to solve for y equals. And the reason we're going to do this is because a function turns x values into y values. Now that we've switched them, we're turning y values into x values. So if f of x is moving forward, f inverse of x is moving backwards. So now that we've switched around our stuff, we are just going to solve for y equals. So now that we're going to solve, we're going to add 2 to both sides. So plus 2 plus 2. So we have x plus 2 equals 3y. And if this is starting to look familiar, it should, because it's what we had earlier. So then we just divide by 3 on both sides. And remember, you divide everything when you divide. So that would mean that x plus 2 over 3 equals y. And in this case, this y is actually our inverse function, which means that our answer right here is our inverse function. Those two are the same thing. So this is a pretty straightforward example of inverting a function, just a little bit of multiplying and subtracting. So what I'm going to do now is I'm going to throw a bit of a curveball at you guys. So we're going to look at one that's a lot less clean, a lot more, at least it looks more difficult. So let's say we have the function f of x equals, let's say it's x over x minus 2. You might be thinking to yourself, oh my goodness, you did it with fractions. Why did you do it with fractions? Why would you do this? So, well, the reason why is because, well, a lot of people don't like fractions, so they don't have as much practice with fractions. So we're gonna go ahead and do this. And the other reason I'm doing it is because this has multiple x's in it. So in this case, when we switch our x's and y's, we need to make sure, so the single y turns into an x, but each of these x's becomes a y value all its own. So now you might be looking at this and you go, oh, thank you. Now, this is terrible. I hate it. because we're dividing by y minus 2, and we don't usually divide by y's. That's a really weird thing. So, what we got to remember is we got to remember SADMAP, right? So SADMAP. Okay, so we can't really do anything with subtraction and addition here because everything is multiplied or divided, right? So division and multiplication, that's where we're at right now. So we've already done that part. We're at division and multiplication. So right now we're dividing by y minus 2, and we really, really, really don't want to do that. So what we're going to do is we're just going to multiply by y minus 2 because the opposite of division is multiplication. So okay, so we'll multiply by y minus 2 on both sides. So we do that. So we wind up with y equals, then we got to distribute the x into the y's. So we get x, y minus 2x. And this isn't exactly the prettiest answer in the world, but it's working so far. So now that we've done that, there's no exponents, there's no parentheses, so we're going to go back up again. So we're going to start with subtraction and addition. Okay, so we want all the y values to be on one side of the equation. So I am going to subtract the term xy to the other side. So the xy cancels. So we've got negative 2x is equal to y minus x times y. Now, this is one of those rare instances where we're going to go a little bit outside of SADMAP. So right now, we have our y is divided, or our y is multiplied into here. So we got y minus x times y. But just like that factoring example I showed you guys a while back, both of these are multiplied by y, which means that if we remove the y from this equation, so y divided by y would leave us with 1, and xy divided by y would leave us with x, that means we factored out the y value. Now we've got negative 2x equals y times 1 minus x. So now we're back on track with SADMAP. So now it's just y multiplied by that thing. So the opposite of multiply would be divide. So we do 1 minus x. We're dividing by that on both sides. 1 minus x. And we wind up with y is equal to negative 2x over 1 minus x. Now, if I remember correctly, I don't think you guys have one like this in the independent practice. You might have one like that in here. But the idea is, even when it's something as ugly as, oh my goodness gracious golly, there's fractions with 2 x's in them, how on earth am I going to do this? We just follow reverse order of operations, maybe factor once or twice, and then we'll be able to make our way to the answer. So our inverse function for this guy is going to be negative 2x over 1 minus x. So we are able to find our inverses, even when they don't look so pretty. We can still just follow the rules of operation and solve, and we'll be able to find it. So with that out of the way, let's go back to the, oh, hold on. Gotta fix there we go. Okay, yep, better. Sorry about that. Clicks. All right, so, yep, so that's an inverse function. And then here we have how to find inverse functions. We already kind of went over that. You change the function name to y equals, you change the x's into y's and the y's into x's, solve for y, whatever your new function is, that's the inverse of the old one. Now, I do want to note, not all functions are invertible. This is a very important thing to note. There are some functions who, when you try to invert them, you don't really get a function, so to speak. So one example of this would be some logarithm functions don't really work this way. So let's cut back over and I will show you a quick example. So let's say we have the function, nope, that's not it. So let's say we have the function f of x equals x squared. Now, I know what you're thinking to yourself. Wait a minute, that's invertible. That's really easy to do. What are you talking about? So let's give this a shot. So y equals x squared. So when we flip this around, we get x equals y squared. And then, square root both sides. Okay, so when we square root both sides, we get square root of x equals y. And then I know what you're thinking to yourself. Oh, okay, so that's the inverse function. So this function is invertible, right? Well, yes and no. So let's look at what these guys look like in specific colors. So let's look at x squared first. So x squared looks like this. So, this is pretty straightforward, nothing too crazy. Whenever you get an inverse function, you flip it over the y equals x axis, which is a straight line that runs kind of like this. So that means when we go to invert this function, we're actually getting this. Now, so far there's not a problem. That's what the square root of x normally looks like, right? Except we also get this. So some of you guys may be familiar with the concept of each x value only has one y value. This is called the horizontal line test. So basically, for any function, the rule is supposed to be, if I draw a straight line up and down on the piece of paper that the function's on, I should never hit the function more than once. It's not a function if I do. So that holds up for x squared, y equals x squared. That function passes that test with flying colors. However, y equals the square root of x doesn't pass it if we include the negative numbers. And this is why on most graphs of the square root of x, they will just not write the negative part of it. They will just leave that off the graph. It is there. It is technically there. You can still get the negative numbers, but for the most part, they just ignore it. They just go, oh, well, that means it wouldn't be a function. So we're just gonna deal with the positive numbers for right now. So be aware that that's a thing that happens. So while it's not a pure reflection of y equals x, the square root function would be considered its inverse because it does the opposite job, even though graphically we tend to kind of ignore that. So, but all of the functions you should be getting should be invertible, if I remember correctly, and most functions are very much invertible. So anyway, so that's how you find an inverse function. Graphing an inverse function, well, I did kind of show you that, but I'll go back and I'll put it on there again so that you can see it. So basically, there is a line, and that line is y equals x. So we're gonna have okay. So y equals x is a line that goes through the x-axis like this. So it's just a simple, good old, you've seen it a million times. Y equals x is a straight line. So whenever you're graphing a function, so let's say that you graph a function that goes like this. So let's say this is f of x. The inverse function is going to be flipped over this as if it were a mirror. So I want you to imagine that the y equals x line is a mirror. If that's the case, then its inverse is going to mirror it across that line. So if f of x looks like that, then f inverse of x would look like this. The easier way to make sure you're doing this right is to just look at some points. So let's say we have this point right here, and this point is 0, 7, right? Okay, so if we mirror that, so instead of going up 7, we're going to go right 7. So the point for the inverse would be 7, 0. So basically, you switch the x and y values of the points. That is how you get an inverted function. So if you just switch the x and y values of the points that you can see for f of x, you'll be able to make f of x inverse. And this is how graphically we create inverse functions. You don't have to necessarily graph them. You can go ahead and do the algebra if you want to, and you have the function written down. You can go ahead and invert it and then just graph that. But on the off chance that you don't have that as the option, just switching the x and y values means that you will have inverted your function no matter what it is. So with that, I believe okay, so that's inverse functions and how to find them both algebraically and graphically. Next time, we're going to be looking at function transformations. Function transformations are going to be a lot of fun. There's a lot of moving and stretching in little bits. Don't worry, we'll go over all the rules, and you will be well prepared for that one. And of course, I'm leaving you guys off on the question I'm going to cover whenever we do the synchronous hour. So that is all for this video. I will see you guys in the next one. Y'all have a great day until then. Bye-bye.